Okay, so this is the first problem on the chapter. So we have a friction coefficient that's given us for this crate as 0.3, and then we are trying to pull in the direction of the P. And then the mass of the crate is 50 kg. The question is that what is the distance and the velocity when the time is 3 seconds and the P is 200 newtons. You can pause the video and then you can check for the forces acting on the body. So we have a weight, we have the normal force, we have a frictional force with the ground, we have P with a component of Px and then Py. Okay. I will select this one as my x-axis and this one was the y-axis. Okay, now time to write the force balance. The first thing is that the Px is P cosine 30. If you know the cosine 30, that is the P times cosine 30 will be 200 times 0.866. And then Py will be equal to P times sine 30. That will be 200 times 1/2. That will be 100 newtons. And this one is 200 times 0.866, 173 newtons. Okay. Then we are going to write the force balance. The force balance in x direction will be that MAX, and then here I assume AX is in positive x direction. So if wrong, if you okay, let's assume that it is wrong, then the problem solution will correct it. Okay, then let's write the forces in x direction. We have the Px, which is 100, so let me register Px, which is positive, minus the frictional force, that will be equal to MAX, and then Px is 173. And Ff is the normal force into friction coefficient, and this is unknown. The mass is 50 kg. Okay. Then time to write the y direction, because I don't know what's n, and I don't know what's the ax. Okay, I need one more equation, which is that forces in y direction is MAY. Y direction, we have the normal force, which is positive, the weight, which is negative, and then we have Py, which is positive. That will be equal to MAY, and then it is 0, no acceleration, which makes sense because the body will not fly up. Okay, so then the normal force is unknown, but the weight is 50 times 9.81. Then Py was 100. If you solve this problem, you will get that n as 50 times 9.81 times minus 100. That makes 301 newtons. Okay, we got the n. So we know n, we know mu k, and we can find the ax. So that will be that 173 minus 301 times mu k. In the problem statement, mu k is 0.3 times 0.3, and that will be equal to 50 times the ax. From here it follows that ax is 173 minus times 0.3 divided by 50 and then 1.11. Okay, that's the acceleration. The question says, find the distance and velocity when the time is 3 seconds. Let's do that. So I know that ax is dvx by dt. Okay, and then separate and integrate. This is the famous friend in dynamics. Okay, so it follows that then dvx is ax into dt. Okay, and then from 0, because the initial velocity is 0, the time is 0, then the velocity is t, and then velocity is vx, and then ax is constant, and I can take it here. It follows that then vx is ax into t. Very simple, relationship. So it follows that then vx versus the time t is linear. Okay, that's good. Now the time is to find the distance. You can replace the time here and then find the velocity, but I will do it at the end. Then I also know that vx is dsx by dt. Separate and integrate. So it means that vx into dt will be equal to dsx. And then from 0 to t, and then, from sx is 0 to sx. And then if I replace the vx value here, then it will follow that ax t, and then we have dt from 0 to t will be equal to then 0 to sx dsx. Okay, and then that will follow that ax t squared by 2 will be equal to sx. Okay, so let me add this note. So you can use the equations instead of deriving. Use equations from the book. So you can use it instead of deriving. Okay, that is the... Okay, so let's now solve it. So from here it will follow that sx will be equal to, then ax is 1.11 times the time is given as 3 seconds, and divide by 2, that will be 1.11 times 9 by 2, 4.5. So let's see, 5 meters. If I made it, I didn't make any mistake. Okay, yes. And then ax by t will be that. So vx will be ax into t, 1.11 times 3, that will be 3.33 meters per second. Okay, that's the end of the problem. So see you in the next problems.